screen of the computer. And so I'll post these in YouTube. If you ever want to look at them, you can, okay? All right. All right, so we're going to, as I said, we're going to look at basic theory. We're going to look at what you do in the field, how to run some calculations. I'm going to have you create notes. So everybody will create their own set of notes every lab period. There'll be a party chief, but also everybody in the crew will create a set of notes. And so part of the class here, this will be to talk a little bit about how crews function and how party chiefs function and how you can work in both of those roles effectively. So we'll talk about that a little bit too. So everybody will be turning in their own notes. So that'll be one of the requirements here of the class, is that you can create your own survey notes. Okay, to be in here, you should have had Math 111. You should be familiar with right-angle trigonometry. So you should be comfortable with right-angle trig and be able to do a little bit of algebra. That's kind of what we do here for math. Okay, the textbook is a survey workbook. It's just a book out of a printed book out of the bookstore there. It has all the stuff that we use for the labs and things like that. And it has the notes that we use here in class. So you want to bring that with you to class every day, every time, okay? Because it has the labs. It also has lecture notes in it. Clothing for wet and cold weather, because on Thursdays we go out and, you know, surveyors don't stay in just because it's raining or something. That's not quite how it works. So get used to that. Now, most of the labs are under the decks here on campus. So just from experience, I don't send you out. You know, usually you're under some type of cover. But all the same, you know, I've seen people out here, and back when people were wearing Bermuda shorts and flip-flops and all that, they were out there in the rain in the Bermuda shorts and flip-flops, and I felt really bad, but they stayed out and did it. And I felt really bad about it, though. I'll show you that, how cold they were and how wet they got. But anyway, get used to that. If you're going to do this type of work, and you know, if you're doing any kind of outdoor work in Oregon, man, learn how to dress for it, and learn what poison oak is, learn some of these basic things so you don't get yourself in too much trouble out there, okay? Okay, and then I would get a survey textbook of some type. You don't need an actual, you know, bound published textbook. Use the notes. That's what we're going to use. It might be good to have a textbook if you'd like, but you don't need to have the newest version of a book here. It's fine. Okay, it's okay. Just get the notes. That's really what you need. Okay, the grading, the homework will be 10%, the labs will be 10%, the exams will be 80%. There'll be a midterm and a final. I just use a straight percentage to when I grade. Okay, I base the lab grades on attendance and accuracy and ability to create professional field notes. Okay, and we'll talk about that a little bit, but just be dang sure someone else can pick up your notes and figure out what the heck you were doing and can read them, and that they look professional. That's what we're looking for in the notes. You got to attend 80% of the labs to pass. Okay, so you can't skip labs here. You got to show up. Okay, also do the basic field operations correctly. If anything comes up, just talk to me. That's kind of that under that professionalism paragraph. So if you're going to be absent for a few days, or if something's come up, just talk to me about it. We'll work something out. Don't just go away and then come back later and try and fix it. Okay, just let me know what's going on and we can work through things. Okay. You know, expect you to show up for class, act professionally here, and that sort of thing. Okay. Okay, final exam was Tuesday from 4:30 to 6:20, and I hope that works for everybody. We got the schedule on the back. You know, we'll be doing a few different things here. We'll basically, the equipment we'll be working with, we'll start off with chains and plumb bobs and stuff like that. We'll use levels. We use total stations, which are a device that shoots an angle and measures, shoots a distance and measures an angle, uses a laser to shoot a distance and measures an angle, and then we'll use GPS too, okay? What do we got here? We've got what employers expect of an employee. That's a good list for students too. So that's a good one to be aware of. We've got a little bit on academic honesty. You know, don't be copying other people's work. Do your own. Work together with other people. That's fine, but do your own work, okay? If you don't do that, you get a 0 for the test or assignment if you're copying. If anybody has any disability issues, just let me know and we'll work them out. No worries there. And then we have an anti-discrimination statement. That we don't tolerate discrimination based on any number of categories there. So we got a lot of different people here. They're all a little different. Just treat people decently regardless of who they are, and I think we'll be okay with that. All right. Any questions on all that? Interesting stuff? Yes?
Do you have a date set for the midterm?
I don't have an exact date for the midterm. Usually it's week 6, so it's a ways out. Things come up, so I don't schedule things quite as tightly as you might have experienced with other instructors. But generally, it's about week 6, is from my recollection. Okay, so it'll be out there a little ways. All right, I've also. All right. Other questions? So why don't we start talking about surveying your bit? It does not yet have the packet. No, if you don't have it, just let me know, because I'm going to give you some of the notes that come from it. We'll get some copies here in a minute. Well, why don't we start? All right. All right, so survey's been going on for a pretty long time. I mean, people have been mapping out routes for a long time. Kind of first formal surveying is probably Egypt and places where they farmed. You know, they'd flood and they'd have to recover the farmers' fields. So they used to have these ropes that were a standard length in Egypt. They'd pull them out, recover the actual farmers' fields where they were at. Okay, and it kind of progressed from there. Classical times, we got buildings, you know, in Greece, aqueducts, which required very good leveling in Rome.
Anybody else not get one?
I think we're good. Okay. Drainage. In India, there were some places that had some really good sewers that were built a long time ago. Roads. Romans are famous for that. So they had this thing called a groma, laid out a nice right angle, and they used water in a long sort of tube to do their leveling. Okay. So that's how they started. Now things got going to a little bit more recognizable stuff in about the 1800s, I think. Compass from China, telescope from Europe. Use those two things. You can come up with a transit and a dumpy level. Okay, so those are a transit turns angles and a dumpy level shoots levels. Okay. Okay, now modern surveying is just going kind of crazy. I was at a surveyor's convention. It was a while back, but man, it was like a Star Wars convention basically. They had laser-based stuff, satellite-based, inertial-based, you name it, they've got it now. So there's lots of ways to measure things. So just be aware of that. You know, there's a lot of ways to figure things out. What surveying I think is turning more into is, well, a lot of things, of course, but you know, you got to figure out where the points are, but then you have to manage all this data in some way. Some of this new stuff, the LiDAR-based stuff and things like that, you generate millions of points. So the problem isn't so much getting the points as it is figuring out to do it with all of them once you got them. You know. Okay, if you go to a local surveyor here, and there's maybe 30 in the Lynn and Benton counties, small, you know, 5-10 person outfits. They're going to use tapes and levels, a theodolite to turn angles, an electronic distance measurement device which shoots a laser to get a distance, and they'll probably have some GPS gear. If they're pretty well funded, they might also have a laser device that shoots out a cloud of lasers to map things. So I was talking to one guy, it was about a year ago, and he goes out in his truck to a job, and he's got a total station to measure angle and distance. He's got GPS, and he's got a laser scanner. And he figures between those three things, he can survey whatever the heck he needs to survey. Okay. That's a tape, okay? So what you do is you stretch that out and measure things. We get a little bit more particular, you know, than some other people might, and how we hold our tapes and how we stretch them and that sort of thing. But that's a rag tape, as it's called. In the old days, they used steel chains with links on them that evolved into steel tapes. But with the advent of laser type surveying for distance, we don't use the steel tapes quite so much, but we always have these rag tapes, we call these, for checking distances and laying out quick distances if we need. Okay. That's a level. That's a newer level, a small short telescope on a tripod. There's a rod, so you can use that to get elevations. There's a total station, which turns angle and distance. It turns angles and shoots distances with a laser. This particular unit bounces the laser off of a prism, and we can determine how far it is from the total station to the prism using this. That's a GPS there. That's the antenna you're looking at. This wire here goes to the data collector down below. Okay, and so that can be used to get position using satellites. This is much more precise and accurate than what you've got in a Garmin or what you've got in your cell phone or whatever. It's a lot more accurate. Okay. All right, basic surveying. What you do is you start with known points and or lines. That's what you call your control. So that's something that's part of the job, less so part of an academic class like this. But when you're really surveying to make a living, you got to find control first is what you've got to do, okay? Now in the old days and still into the new days, we look for control points in the ground, monuments that are set by government agencies, property corners that are set, things like that. We also now have control that orbits the Earth with GPS. That can be, those satellites can be thought of as a type of control. Once we can establish our location using control, then we can use our survey equipment to set new points and lines, okay? But there's always this element of finding control and using it to establish where you are, okay? And there's lots of ways to do that, but that's always a step that you have to start with, okay? Now, if you're interested in this kind of work, and I think it's really interesting work. It's fun. It's got a lot of good things to it. You get to be outside a lot and see a lot of new country. It's physical work, but it's not the kind of physical work I think that breaks you down like digging ditches for 30 years would do. It's you're out moving around, but you're not beating yourself up quite so bad. And also, you got to be pretty sharp cookie to do this stuff and do it effectively. You got to be thinking all the time. And so it combines all those things, and it's interesting work, really. To do this, you got to use math. We use that a lot of geometry, of course, to figure out where points are at. You also have to know land law, usually, unless you just stick with construction surveying. So not only do you have to know like the calculations and such, but you also got to know the precedent for how to set corners, where to put them, and what sort of laws and regulations govern how you do that. You got to learn how to use equipment, and you got to be able to manage a crew. So those are the things the skills that you'd need to really do this for a living. Okay. Now there's lots of types of surveying. Some of the basic categories that you run into is land surveying or property surveying. That establishes property boundaries, and this uses high levels of precision and accuracy, okay? So people get very, very serious about where their property corners are, and so you get that stuff on where it's supposed to be. You don't mess around with property surveying. You put those corners where they belong, and it's that, that's how that goes, all right? Okay, now there's construction surveying, which is a different breed of cat. Construction surveying is setting construction stakes, or nowadays with more GPS controlled equipment, it'd be setting construction control. And the idea here is construction surveyors move faster than land surveyors usually. I don't know, it might not be completely accurate, but that's kind of the idea. Construction surveying, quite often, if you get the stuff within a pie plate, you're good. So you don't waste time setting it to the 100th of a foot sometimes. If you're setting a manhole, you get that stake in the ground and move on down the road and get the next one in the ground. It's more the attitude with construction, okay? And I worked with a fellow that was a BLM surveyor, Bureau of Land Management. He used to recover BLM corners, which is land surveying and kind of a very high precision land surveying. That fellow just wasn't much of a construction surveyor because he just didn't have the right attitude. He wanted to check and recheck and check this and check that, and hey, to heck with that, man. Get them corners, get those stakes in the ground and get on down the road is kind of how they look at it in construction surveying. Okay, it's a little different, all right? Guy I worked with, we used to do this stuff. We were surveying in some roads, and there was the crew that set the curb and gutter, the concrete crew. This was back before a lot of those curb and gutter machines where they actually built formwork and poured it and did all that to build a curb and gutter. And these were kind of big guys that carried sledgehammers around and all that kind of stuff. And my friend said to one of them, "Hey, how you doing this morning?" And the guy just looked at him and growled and said, "We're right on your tail. Get those corners and get those stakes in the ground, man." So he wasn't too interested in being friendly. He was more interested in getting the stakes in the ground so they could build that curb, okay? Okay, geodetic surveying considers curvature of the earth, okay? So if you're building I-5, back when that was built from Washington down to California, they had to do geodetic surveying where they really looked at the curvature of the earth and how it affected the lengths of the lines and the angles, okay? So the people that do this are usually pretty good at math, they're very good at math, and use a lot of high-tech equipment, okay? Now there's lots of other types of surveying, but those are the three main ones that I've run into over the years, so when you're doing this stuff, see, you want to have some idea what you're doing and what the precision and accuracy requirements are. You know, you don't want to waste time. Time's money, okay? So, you know, if you're doing land surveying, you take the time to make sure that corner is right where it's supposed to be, that property corner. But if you're doing construction surveying, you don't take as much time because you just can't afford to, okay? So you got to kind of know what it is you're up to so you can do it the right way. That's the idea here. All right, so a land surveyor would create a map looks like that. So what they've got there is the lot that they surveyed, and they've got a whole lot of legal text on this thing. This would be a map that's turned into the county surveyor to record the survey that surveyed out this lot down here. So they got a legend, and they've got a narrative which says what they were doing out there. They've got a property description here which describes how to walk around the property. They've got the client's name and where the stuff's located. They've got the surveyor's stamp on there. And they've got a bunch of sign-offs for the property owners and the county tax collector and surveyor and all that to sign. Okay. So a zoom in on that survey looks like that, see? So what they've done on this one is somebody had a 5-acre parcel. They wanted to set 2 corners on this thing to split it into 2 2.5-acre parcels. Okay. So they set that line. So when they did that, they set property corners. And when you do that, you got to go to the county surveyor's office and turn in a map that looks like that tells what the heck you did. Okay? So anytime you mess with property corners, you've got to submit a map to the county surveyor. Okay? Construction surveying is setting stakes in the ground. So like, for instance, a sewer can be built. That's construction surveying. Okay. Geodetic surveying would concern itself with a long survey or a big one, like I-5, something like that. That you have to consider the curvature of the earth. Okay. All right, now what a surveyor generally wants to achieve if they want to make their living doing surveying is they want to become a registered land surveyor or professional land surveyor. All right. So if you want to do this, you're licensed by the state board called OSBEALS, Oregon State Board of Engineers. Can't remember what that second E is. And then here's LS for land surveyors. Okay. You got to have enough education in Oregon. It's 4 years. You got to pass the LSIT test, which is a land surveyor in training. You got to have, I think it's 4 years of experience here in Oregon, and then pass a professional exam, which covers land law primarily. So if you want to set a property corner, you got to be an RLS in Oregon, okay? And they stamp the drawing that's turned into the county. Okay? So if you want to do this kind of surveying where you're setting property corners, you got to be an RLS, registered land surveyor. And you would submit a map like that, and you would stamp it right there, saying, I certify this was done the right way, that those corners are where they're supposed to be. Okay. Now, if you want to be a registered land surveyor, which is a good thing for a small consultant to be, I think if you go to, now I can't remember the exact number of credits, but you can go to OSU, you can measure in CEM, and for your electives, take at least 16 credits of surveying classes, I think it is. And then you can sit for the LSIT exam, and once you've got that, you can take the professional land surveyor's exam, okay? So that's the rule here in Oregon. Right, now when we're doing surveying, we got to get used to a number of things, because what surveyors do for a living is measure stuff. So they take their measurements very seriously, okay? So let's look at some things about this. So this is in that handout, so you can have a look at that. Now the first thing is, now in this country we still use the English system of measuring, called the imperial system sometimes. And that doesn't work very well for what we want to do. So surveyors do not use the standard feet and inches that carpenters use and architects. We don't do it that way, okay? So I don't want to hear the word inch in this class unless you're talking about drawing a map. Okay? When we're surveying stuff, we don't use inches. We just don't, period, okay? So, and here's the reason. If I got these two measurements and I want to add them up, what the heck am I going to do here? I guess I take that 5/8 and I turn it into 10/16. And then I'd add 10 and 9 and get 19/16. I'd add 8 and 7 and get 15 inches. And add 37 and 24 and I get what? 1, carry the 1, is that 61? Okay, then I carry a 16/16 over and I get 16 inches and that'd leave me 3/16. 61, and then I carry 12 inches over and I get 62 feet 4 and what, 3/16 inches? Is that what I get? I think. And see, that's a heck of a lot of work just to add two distances together. It's kind of dumb, really. You can see why people like the metric system better. And see, so a surveyor would not measure the distances like that, because it's dumb, okay? What they do, they use decimal feet. It's like a metric foot, essentially. You take a foot and you break it up into hundredths. And these are the same two distances that have been converted to decimal feet, and, you know, I can do this pretty easy. 62.35 feet, and I'm done, okay? So that's how that works. So we don't use inches here. We just don't. And it's just not done, okay? So we good with that? And that's on page 2 or thereabouts in your notes, eh? Okay. We good with that? So decimal feet, that's how we measure. And there you can see some equipment. You see it's broken up into decimal feet. Okay, see the level there, or the rod? We've got the red numbers are even feet. So I got 4, and I got 5. And then I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I go to 5 feet. See, those divisions between like the 8 and the 9, those aren't inches. Those are 1/10 of a foot, is what they are. A little bit longer than an inch, okay? Same thing here. Here's a tape. Hard to see, but if you look at 4/10 and 5, there's 10 marks between 4 and 5. That's not an inch. That's 1/10 of a foot, okay? So that's how that goes. So remember that and get used to that. Now, unfortunately, we still use stupid angular measurements, though. It's too bad, but we do. And those are degrees, minutes, and seconds. And this goes back to like ancient Sumeria, like 5,000 years ago, okay? Where they, for some reason, they like to break things up into units of 60, which, you know, that's divisible by a lot of numbers. I kind of understand why they did it that way, but all the same, it makes things a little bit difficult. So a circle is 60 degrees, but 1 degree is not nearly a good enough unit to measure angles with in surveying. So we take a degree, and just like with time on our clocks, we break a degree up into 60 minutes. But even a minute is not a fine enough angular measurement. So we take a minute and we divide it into 60 seconds. Okay? So when you measure angles, you call them out by degree, minutes, and seconds. Okay? That's how we call them out. And unfortunately, this is kind of a stupid way to do measurements for angles. Corps of Engineers has something called gradients, which actually are a pretty good idea. They take a right angle, they break it up into 100 grads, and then they use decimal from there, but unfortunately we don't use that so much anywhere else. Okay. So sometimes we might have to convert between degrees and between minutes and seconds and decimal. So 41 degrees, what is that with degrees, minutes, and seconds? How many minutes is 0.5 degrees? Yeah, I think 30, okay. 86.25. Yeah, I think 15, eh? That's a 0.25 of 60 is 15. 2230 is 22.5. Okay. So we'll get more into converting these. But just keep that in mind. Unfortunately, it's not a very convenient unit to do the arithmetic with. Okay. All right. Now rounding. Round. Do not truncate. Okay. We get really particular about this. I got spoken to once by a guy I worked for once because he didn't like some rounding I was doing. Okay. And he wasn't an academic kind of guy. He was a working kind of guy, a surveyor. And I wasn't rounding the way he liked. And so he told me about it. And he didn't always use polite language when he told me about that. Okay. So I can't remember. But it wasn't, anyway. Yeah, he was pretty direct, I think. Yeah. Okay. Okay, so round, do not truncate. Let's round these numbers to the nearest foot. Or how about the nearest tenth? Let's round it to the nearest tenth. And let's see what I mean by that. So let's say we've measured the heck out of this thing, and we got 14.5372 feet, and we want to round it to the nearest, let's say nearest hundredth of a foot. What would you round it to? 0.54, right? Because we're going to the nearest hundredth. The numbers after that are bigger than 50, so we round up, right? Now, what if I truncated it? What would it look like? What does truncate mean? Truncating is you cut off the last two digits. We don't do that. We round. And remember this, surveyors do this stuff for a living. They measure stuff for a living. They take it very seriously. So don't truncate. You just don't do that, okay? That's not right. And surveyors get sued about stuff all the time, stupid little things you wouldn't believe, and they don't want to get sued, okay? That's bad for business, so they don't round. That's how we do that, okay? So don't truncate, okay? We don't do that. Now, so you identify what you're rounding to, and then look at the column to the right. If it's greater than or equal to 5, round up. If it's less than 5, round down. If it's right on 5, there's different tricks you can use on that. Someone who's really good at running an instrument will remember that in their head, and they'll round the first one up, the next one down, first one up, the next one down. I don't get quite that precise about it, but I've heard of people doing that just to get things to kind of even out. Okay. So all you got to do here, if you want to round these to the hundredth of a foot, is first identify the column you're rounding to, and then round either up or down. So 6743, right? 4128, 8126. We good with that? Okay. Now, significant figures. This is important too. The general rule is only report what you measure. Okay? Now, surveyors generally measure to 100th of a foot, but not always. So you report what you measure. Okay? So if I pull a tape here, and let's say my tape measures to the 10th, that's what I would write down. If I wrote this down like that, that's not right, okay? Because I didn't measure it to the 100th. I measured it to the 10th, okay? And if you do this for a living, you take it seriously, okay? So watch this stuff. Don't get sloppy, okay? And here's what I got to do a little trouble with. Okay, let's say we get an average distance. We measured these two distances. The same line twice, we got two distances. What's the average distance? What would you report the average distance as? Any ideas on this?
64.7.
Yeah, see that the thing, if you run that on your calculator, you're going to get that, aren't you? And this is what I did when I was working. I was figuring out some earthwork, and I did this on cross sections. And the boss got all over me for that. See? And again, he's not some academic guy wearing his mortarboard all around. He's not that kind of person. He's a construction person, okay? You don't do that, man. He's saying, come on, what's the problem here? What am I saying? I'm saying we measured it to the 100th, aren't we? Well, we didn't. So if I'm going to take 64.8 and 64.5 and measure them, probably I want to write down 64.7, okay? And he was quite serious. He wasn't kidding around at all, okay? All right? So just be aware of this stuff, okay? Y'all okay with that? Okay, let's do a couple more terms here, then we'll take a break. But let's do a couple more terms here first. Now, error, okay? Error is the difference between what you measure and what the actual value is. Okay? Now, all surveys have error. This is an inevitable part of surveying. It always happens. You always have error. What you try and do is know what the sources of error are, minimize them as much as you can, and compensate for it. But anytime you measure something, you're going to have error. You can't get an exact answer. There's just no way, okay? Now, things that can cause error, there's natural error, weather, atmosphere. You ever look down a road on a hot day and seen heat waves? You ever try and sight a point looking through heat waves? A little tough, okay? What does heat do to the metal instruments? Makes them expand a little bit. The metal tape doesn't read accurately when it's really hot. The atmosphere affects things that we shoot. There's natural errors all over the place. Okay, there's instrumental errors. Machinists can't make a perfect instrument. They can't make the scale on it perfect. It's not achievable, okay? Different people sight a little differently. There's a lot more going on with your eyes than you realize when when you're looking around even and when you sight. Some people will look a little left, some people a little right. It's a normal thing, okay? So these are types of error. They come up all the time. All right. I remember once we had to sight a corner and there was a fence. Whenever you're surveying, you'll find out about all this stuff that can get in your way. There was a fence in front of the corner and there really wasn't a good place to stand, so you kind of had to perch on I can't remember, maybe it was on the fence or something, take a plumb bob on a string and drop it on the point. And there was a heck of a wind blowing that day. So what the person surveying with the instrument is trying to do as they're looking at this is sight this string. Now what do you suppose is happening with the string? It's swaying, right? Yeah, it's moving. All right, so that's error. Now, if the wind isn't blowing too bad, what do you suppose you do to get the best results you can get? Sight, where would you sight if this string is swaying? Top, actually the lower the better on a string like that. Well, okay, I think kind of the idea of what you're getting at would be the middle of the swing, right? Where you assume that person's trying to hold that plumb bob on the point, and as that plumb bob sways a little bit, you hope that on average, that's when they're over the point. Sometimes they swing left, sometimes they swing right. So I try and sight down the middle, which I guess you'd say kind of near the top. Yeah, near the top, okay? That's how you try and compensate for that, okay? But, if it's a windy day, it's probably going to push that plumb bob over a little bit. You got all sorts of stuff going on here. So surveyors want to know about this stuff and compensate for it. Another example of this would be, we're going to go out and we're going to do a traverse where we shoot at distance on the mirror. We'll carry a prism and we'll have a glass up here, so the distance is shot on the mirror, and then this person's going to be on the prism holding that. So when you shoot the distance, you want to shoot on the mirror, of course, because that way you get the beam reflects back to you and you can measure the distance. But where do you want to shoot the angle to get the best angle you can get on that rod, high or low? As that person's trying to hold steady, and you'll see him sway a little bit. Low, yeah. So someone who's good at this, who understands it and does it properly, they'll aim high, shoot the distance, then drop their telescope down or use that crosshair and get the angle down there. See, they'll get the distance on the glass, angle down below, because it's a better angle down there. Okay. So these are just some things to think about. Okay. Now there's two kinds of errors. There's systematic. Those conform to natural laws. They can accumulate. I.e., if it's a hot day and your metal tape is expanded and it's too long, okay, that would get you a systematic error. That tape's a little bit too long when it measures. Random conform to laws of probability. The swing on a plumb bob string, okay? So standard surveying equipment is a plumb bob. It's a brass cone on a string with something called a gammon reel up top. Well, somebody can't hold that directly on a point. If they're holding it high, they'll swing left and right. You'll get random error associated with that as that plumb bob swings, okay? So if you're surveying, generally speaking, there ain't much you can do about that, and it's going to cancel out anyway. Sometimes it'll be left, sometimes it'll be right. Over time, they'll tend to cancel out and conform to the laws of probability. This is the one that'll get you. Systematic error. You've got to really watch that and try and reduce it and learn how to correct for it, okay? So there's ways of checking angles and doing things like that. And you know, if you're surveying, you hear all kinds of stories about this stuff. The guy I worked for, they were shooting an angle and they couldn't get the thing to check properly. And they were shooting the thing near a tree. That's a tree. Here's the tree root that just happened to go under the instrument. And when they turned to get to that angle, that tree root came out of the ground. And they were stepping on that tree root every time they went over. That tilted the instrument a little bit. Kept throwing them off. They couldn't figure that out, but eventually they did. Okay. So all sorts of these little things come up. So if you're a surveyor, you depend on probability to make that one go away, okay? If you use proper technique, that'll cancel out. Here's the one you worry about, systematic error. That's not good, okay? Because it adds up, okay? Now I'll contrast that with a mistake. Mistakes are not errors. Mistakes are a blunder. Mistakes are reading an 8 when it actually was a 6, okay? So these are different terms. They mean very different things. You do not expect this to happen. This isn't good, okay? That's different than an error. An error happens. You try and correct it out. But a mistake will screw you up a lot, okay? Okay, another couple definitions here. Precision and accuracy. Precision is repeatability. It's if you did the same survey twice, you'd get similar results. Precision usually comes with proper technique. You can measure this as you're doing it, okay? Accuracy is how near a true value your measurement is. Surveyors strive for high precision because generally speaking, if you're using the equipment properly and using proper technique, you'll have high precision. That often leads to high accuracy, but not always, because you have the variable of your equipment in there. So if you use a compass You could do a very precise survey, but a compass is not a particularly accurate instrument to do surveying with. So precision doesn't always lead to accuracy. It's an important step in accuracy, but just because you're precise, it doesn't mean you're accurate. So quite often in our surveying, though, we'll call out the precision that we expect. Okay? All right, so that's just a little bit of introductory stuff here. Why don't we take a break here for 5 minutes, let's say, and then we'll carry on with a little bit of distance measuring type stuff.